All right, so the first problem I want to do here with solids revolution is taking the area between square root of x, y equals 2, and x equals 0, so that's this area here, and rotating that around the x-axis. I think this is part A of number 31. So if we're going around the x-axis, then we need to sketch in a rectangle that is perpendicular to the axis of revolution. So it looks like that. And so you can imagine spinning this and the area, and if you spin the rectangle around the axis, you're going to get a washer, because there's going to be a hole when you spin it. So if you imagine this popping out the other side, like this, more or less, you can imagine you'd get this washer looking thing here. Okay. So anyway, the question then is, what is the big radius for washers? What is the big radius and what is the small radius? Or the outside radius and the inside radius? So the outside radius is going to be 2. It's 2 wherever you put the rectangle. This distance here is always going to be 2. If you put the rectangle over here, the distance is still going to be 2 for the outside radius. The inside radius then is going to be defined by the function, okay? And that is square root of x. So the inside radius is root x, the outside radius is 2. We use the formula for volumes using washer method. So it's v equals pi times the integral from 0 to 4. We're on the x-axis here. And we're going to take the big radius squared, so 2 squared minus square root of x squared, all with respect to x. And that'll give you the volume. Trust that you can plug that into your calculator and get the answer. One last thing I would say is that we know we're in terms of x for a couple reasons. One, we're going around a horizontal axis using the washer method, so that means that we have to be in terms of x. The other reason is that this rectangle is we're going to take an infinite number of rectangles and it's going to shrink in the horizontal direction. In other words, the width of the rectangle is dx. That means, also tells us that it should be in terms of x.